Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our Java Interview Questions course. In this course, we're going to be covering data structures and algorithms through the most common Java interview questions. So let's go ahead and take a look at what will be in this course. We're going to be covering 10 different sections with the top 10 most common topics asked at interviews at FANG companies such as Amazon, Microsoft, Google, Netflix, etc. Let's go ahead and look at each section in turn and give an introduction. So first, in section 1, we're going to be answering some string and array interview question. Strings and arrays are commonly worked together, and we're going to be looking at some of the most common problems that involve using strings and arrays. In section 2, we're going to be covering matrices. So we're going to look at matrix interview questions. Matrix is another data structure, and we're going to be looking at how it is used and some questions that you might get asked about it. In section 3, we're going to be covering linked lists. The linked list is another type of data structure, and we're going to be covering how you can use it through some interview questions. In section 4, we're going to be looking at trees. So still continuing on with data structures, we're going to be looking at the tree this time. We're going to look at the binary tree and some of the common interview questions asked about trees. In section 5, we're going to look at graphs. Graphs are another data structure. We're going to look at how to build a graph as well as how to use graphs through interview questions. In section 6, we're going to look at sorting questions. So we're going to look at how to sort through data structures like lists. In this section, we're also going to introduce time complexity. We're going to talk about the time complexity of the most common sorting algorithms. Time complexity is often asked with every interview question. In section 7, we're going to cover dynamic programming and the interview questions that might be asked about that. Dynamic programming is a way of solving interview questions that will increase, or rather better, the time complexity. Next, we're going to cover bit manipulation and interview questions pertaining to this type of way of structuring your algorithms and solving problems. In section 9, we are going to be covering combinations and permutations. These are two types of ways to sort through and to select through, rather, different data structures. And we're going to be covering the difference between the two and as well as how the two are commonly used in questions. And finally, in section 10, we're going to be covering some math interview questions. Math is quite a broad topic, so we're going to be covering some of the most common interview questions that have to do with math and all of the various categories in math. Well, that is everything for our introduction. We will see you in the first lecture, where we're going to be covering the most commonly asked interview question known as FizzBuzz, a quick starter to get you up and running before we dive into all of these topics. We'll see you in the next lecture. Hello everyone, and welcome back to our Java interview questions series. In this lecture, we're going to be solving the interview question of FizzBuzz. This is an extremely common beginner's interview question, and we're going to be covering it in this quick win. So the FizzBuzz question is right here. Write a program that prints the numbers from 1 to 100, but for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. So before we actually write code for the solution, we're going to think about what the solution might be and write some pseudocode, which means it's half English, might include some code, but this is how you want to tackle every problem. Whenever you get an interview question, first you start with pseudocode, and then you can refactor it into real code. So we can do all of our testing in the main method for this FizzBuzz problem. And we can begin by, let's see, it wants us to print numbers from 1 to 100. So we're going to have to loop through from 1 to 100. So first we're going to need to make a for loop. And the for loop will start at 1 and it will end at 100. Now this is just pseudocode right here. in our real code, and we will refactor it once we have the whole solution understood, and once we know exactly what we want the program to look like, then we can refactor it into real code. But while you're still thinking of the actual solution and deciding on the best possible solution that you want to tackle and use, you can use pseudocode. So we're going to make a for loop for this solution, and then we're going to have to implement a test each time that it loops from 1 to 100. Well, the question is asking us to print the numbers, but if it's a multiple of 3, don't print the number, print fizz instead. So we're going to have to make a check. So if number is 3, and if the number is 3, we're going to print fizz. So print fizz. So that enables our check for if the number is 3. And then it says if the number is a multiple of 5. Okay, so it's not actually if the number is 3. It's if the number is a multiple of 3. So that's a key difference here. So we can't just test if the number is 3. We must use something to test if the number is a multiple of 3. Or rather, yes, if the number can be divided by 3. So how do we test for division? Well, we can use testing for remainders. So we can use the modulus operator. So if the current numbers, modulus operator divided by 3 is 0. So this will enable us to test if the number is divisible by 3 evenly, if the modulus operator returns a remainder of 0. Okay, then we'll print fizz. Then we're going to have to do a test if the number is a multiple of 5. So for this, we're going to use else if the current numbers modulus operator is divided by 5 is 0. So this will test if the number is divisible by 5 evenly, and that would make it a multiple of 5. Okay, because of course a multiple means that it will go into 5 evenly. Okay, next we want to else. Otherwise, we want to print the number. However, we also have to account for if the current number is divisible by 3 and divisible by 5. So we should test that first. So if current number is divisible by 3 and 5, then we want to print both fizz and buzz. Okay, and that should be first because it will be the first test, and then these will be else if statements. Okay, amazing. Looks like we got our solution here. That seems to be everything we need to do. What we can do next is turn this pseudocode into real code and then test it to see that we actually get the solution we expect. So let's go ahead and actually turn this into real code. So what are we expecting for the solution? Well, we're expecting something like printing first, so it will print 1, then 2, and then the 3 would be a multiple of 3, so it would print fizz. And then it would print 4, but then for 5, that is a multiple of 5, so it would print buzz. And then for 6, that's a multiple of 3, so it would print fizz again. Without the quotation marks, it would not print these quotations. And so forth up to 100, which 100 is a multiple of 5, so it would end at buzz. So we're expecting something like this from our output. So let's go ahead and write some code that we can then test to see if we get this output. So let's go ahead. First, we need to change the for loop's condition. We want to start at 1 and end at 100. So we're going to need to make a counter. This will be a for each loop. So just like that, with the for keyword, it initializes a for each loop. And we can change the condition here. So we're going to start with an integer count. And we want to start at 1 because we're printing numbers from 1 to 100. So int count equals 1. That is our starting condition. And then we need to have the ending condition because this is a for each loop. So the ending condition is when count is 100. So that means we want to put count is less than or equal to 100. Okay, and then to finish the for each loop's header, we need to increment count. And we want to increment it by 1 each time because we're going to be checking each number from 1 to 100. So we'll add count plus plus. Okay, great. That is everything for our for each loop's condition. Then we want to change this pseudocode into real code. Okay, we want to test if the current number is divisible by 3 and by 5 evenly. Okay, let's go ahead and test that. If count, which is the current number, count mod 3 is equal to 0. So if count mod 3 is equal to 0, that means that the count divided by 3 leaves no remainder. So for example, 6 divided by 3 has no remainder because it goes into it evenly. So this modulus operator will allow us to check if the number is a multiple of 3. And we want to check in the first condition if it's divisible by 3 and 5. We want to check those two first. So we're going to use the AND operator here to combine two conditions. And the second condition will be if the count mod 5 this time. Oops, mod 5. That's the percentage symbol here. If count mod 5 is equal to 0 as well, then we'll print fizz buzz. Okay, now that we have our first if condition to check if both of these conditions are true, we can now test if each condition is true. So our next if statement should check if the current count mod 3 is equal to 0. So if the count mod 3 is equal to 0, that means the current number is divisible by 3. So that makes it a multiple of 3. Therefore, we can print fizz. Okay, perfect. We have that else if statement done. Now I want to change this pseudocode into real code. So else if count mod 5 is equal to 0, then we're going to print buzz. Print buzz. And we have to change this print word to System.out.println. So let's go ahead and do that. System.out.println. If you have Eclipse, you can use sysout and then hit Control Space to autocomplete it. But we're using REPL here, so we don't have that autocomplete. So just type System.out.println. This will print the actual line. Using a simple print word won't print the line. You have to call the system class .out and then its print line method to print a line out into the console. Okay, great. Here we have System.out.println. And this will allow us to print fizz or fizz buzz depending on what number we're at. Okay, great. The else statement, now that will account for every number that is not divisible by 3 or 5. And in that case, we just want to print the number. So we can go System.out.println and just print the value of count at that time. And then it will be incremented as we stated in the header. Okay, now we can delete this default print line. It just came whenever you made a REPL project. Okay, let's see. Have we done everything? We have created a for loop to go through each number from 1 to 100. Then we tested if the current number is divisible by 3 and 5. And then if it's divisible by 3, or if it's divisible by 5, or if it's not divisible by 3 or 5. Okay, that is every condition accounted for. Let's go ahead and hit run to test this project. And then we should expect to see this kind of output in the console. Okay, great. Let's go ahead and expand the console and zoom in to see what we have here. Well, see at the very top we begin with 1, 2, and then for 3 we have fizz, for 4 we have 4, for 5 we have buzz. Okay, amazing. For 6 we have fizz, great, 7, 8. Let's see if we get fizz buzz. Aha, for 15, which is divisible by 3 and 5, we get fizz buzz. Perfect. Okay, that means that our code was printed as expected. That means we solved this FizzBuzz question. If your code isn't solving, make sure to check the source code against ours to make sure you have everything as we have written it. Great job, everyone who just solved the FizzBuzz problem. Congratulations, and we will see you in the next lecture. Hello, everyone, and welcome back to our Java interview questions series. In this lecture, we're going to be solving the interview question, reverse words in a string. So let's take a look at the question here. Given an input string, reverse the string word by word. A word is defined as a sequence of non-space characters, so any character without a space. The input string does not contain leading or trailing spaces, and the words are always separated by a single space. Okay, so what it's saying is if you had an input such as, for example, Leonardo da Vinci, that would be a input string, and each word is considered, the character is separated by a space and only a single space. So if we had this as the input, we would expect an output of the reverse. So it would be Vinci da Leonardo. Okay, great. Let's go ahead and look at how we can go about solving this. We can solve this right in our main method here. So first we're going to need an input string, and we're going to need a variable to represent that input string. So let's go ahead and make a string called input string. Now instead of just being a string, we're going to actually make this an array of strings. So that way we can reverse each word in the array. So we can reverse each element in the array. So let's set this equal to our example, Leonardo da Vinci. So Leonardo da Vinci. So this is a string, and then in order to make it into an array, we can split it by using the split method. So the string class comes with a split method, and we can split it at each of the spaces. So wherever the split method finds a space, it will split the string and put that element into that array. Okay, now we need another variable to represent the reversed string. So currently we have just the input, now we need to actually reverse it. So let's represent that as reversed string. This will be initially just a blank string. Okay, now we actually have to reverse the input and store that in reverse string. So how would we do this? Well, we're going to take a loop to loop through each index in the string. So let's make a for each loop. We're going to start at index of the last letter. So we're going to start at the last letter here and use that to reverse the string. So we're going to start at the last letter and put that into the first element of reverse string, and then take the next one, and so forth. And this way we're going to move backwards through the input and place that into the reverse string. So let's begin at the last letter. So that will be input string dot length -1. So that would be the last word, actually, because input string is an array of words. So this will actually be the last word. Okay. Now we're going to increment. So we're going to need the maximum, or the end, where we're going to end. We're going to finish when the index is 0. So as soon as the index hits 0, the first word, we're going to stop the loop. Now we need to increment. And how are we going to increment? Well, we're going to subtract 1 each time to go backwards through each word. Okay, great. That's the header for our for each loop. Now we actually need the body. So what are we going to do inside? What are we going to do at each word? Well, we're going to take reverse string and we're going to append it to that word. So because this is an array, each element that we're looping through is an element. So let's actually, you can change this to word because that makes more sense, because it's getting the word. Okay, so reverse string plus equals the input string word. So at the current word, we're going to take it and add it to the reverse string. And because we're going backwards, it will add it backwards. Okay, great. And we're also going to need a space. So just add a space there. That way each word will be separated by a space. Excellent. Okay, that is what we need for our for each loop. Let's go ahead and actually print out the results. So that way we can test this in the console. So go ahead and type System.out.println. And we're going to print reversed string dot substring. And we're going to begin at 0 and end at reverse string dot length -1. So this will print a substring from 0 to the final. Okay, let's go ahead and hit run. And what are we expecting? Well, we're expecting the reversed of our input, which we defined initially as Leonardo da Vinci. Go ahead and hit run and let's see. Yes, okay. In the console, you should see printed Vinci da Leonardo. If you try this with another string, as long as it's separated by spaces, it should be reversed. If you're seeing any problems, just make sure to check it against our code. Okay, great job, everyone. You just solved the interview question, reverse words in a string in Java. Thank you for watching, and we will see you in the next lecture. Hello everyone, and welcome back to our Java interview questions series. In this lecture, we're going to be solving the interview question rotate array, specifically rotate an array of n elements to the left by k steps. So what does this look like? Well, rotate an array of n elements. So suppose we had an array of 7 elements. That would look something like 1, 2, 3, 4, 5, 6, 7. That here is 7 elements in an array. And if we want to rotate it to the left by k steps, well, suppose we had k equal to 3. That would mean that from the left, it would be rotated. So the first value would be shoved to the end, and the second value would be shoved to the end, and so forth by k number of times. So if k was 3, then we would expect something like 4, 5, 6, 7, 1, 2, 3, because it took the first 3 by k steps and move them all to the back. Okay, great. Let's look at how we can solve this. So if this was the input, how would we get this as the output? Well, let's go ahead and solve this by making a new class below our main class. We can call this class something like rotate array, class rotate array. And now we can make a function to rotate the array to the left. Now there is a difference between rotating to the left versus rotating to the right. And this question is asking us to rotate it to the left. But if we were to rotate it to the right, that would mean we would take the elements from the end and rotate them to the front versus taking the elements from the front and rotating them to the back. Okay, so we're rotating to the left in this case. So we have a class rotate array. So let's make a function to rotate to the left, void left rotate. Okay, and this is going to take in an integer of array. So an integer array. And that is the integer array we made up here. Now we're also going to need the n. So this will be the size of the array. And we're also going to need k, so the steps. So let's first make k. So k will be the rotate by variable. So this is how many steps we want to rotate it by. Then we're going to also need the int size, so that would be n for size. Okay. If you want, you can call this k and this n, but for the purpose of this example, we're going to keep the wording very clear. Okay, now we have the header of the function set up. Let's go ahead and left rotate. So how do we do this? We're going to need a loop to loop through each element in the array and rotate it. So let's make a for each loop. We're going to start at the first index in the array, so the first integer, and we're going to go until the last, so until the size. So while index is less than rotate by. So we're going to go until we hit the k, because k means the number of times we want to move the first index to the end. So after, if k was 3, then we stop after 3. So that's why the condition will end when we hit rotate by. Okay, great. Now we also want to increment the index each time. Perfect. Now our for each loop's header is set up. What do we need to do next? Well, we want to, at each index until we hit k, we want to move that element to the end. So in other words, left rotate it. So we're going to have to make another function to do that. Let's go ahead and call that left rotate. Left rotate by 1, for example. And it's going to take in that array and also the size. So that way it can work on the same array as up here and its same size. Okay, let's go ahead and make that second function. So where are we going to do this? We're going to do this outside of this function. So let's call it void left rotate by 1. And it's going to take in an array as well as size. And that corresponds to what we planned up here. Okay, so this is the plan for left rotation by 1. So this method up here, it just goes through each index, but then this method down here will actually rotate each index. So we're going to need to make an integer for index, make an integer for a temporary array that will represent the array. Okay, let's assign temp array to equal the array at the first index. So we're going to begin at element 1. Or rather element 0, the first element. So that will be the first one, and then we're going to left rotate it to the end. So how do we do this? Well, we're going to make another for each loop. We're going to begin at 0. We're going to go until the size -1. And then we're going to increment it. Okay, excellent. And in here, we want to get the current index. So this is going through each element in the array. And it's going to assign it to the next index. So in this way, we're taking the current index and we are assigning it to the value of the next one to shift them all. Okay. Let's see. Excellent. Now what we need to do is take the array at the current index and assign it to the temp array to finish the temp array to go from the 0th to the next. Okay, excellent. What do we need to do next? Well, now we actually have to test that this solution works. So we're going to make a print function so that we can print all the values. Let's go ahead and make a function called print array. It's going to take in that same array, and again, it has to go through each element, so we need its size. We're going to make another for each loop to begin at 0 until the end, and increment it each time. Okay. Great. So now we have a for each loop set up to print all the elements in the array. And inside of this, we're going to go System.out.println. We're going to take the current element and print it to the console. Okay, excellent. What do we need next? Well, we're going to need to test this. We have, so far, we have a left rotate method to rotate through the array, and we have a left rotate by 1 to actually work on each index. So we split this into several methods to make it cleaner. Then we have the print array method to actually print the elements. We're going to print them to make sure that they actually rotated. Okay, to test this, we need to open our application with a main method. So let's go ahead and write some test functionality in the main method. We're going to first need to make a rotate array class. So we can call it rotate array equals new rotate array. Now that we have made an object for a rotate array, we can actually call its method. So first we need to make an array. So let's use this example because we know what we expect the output to be. So we're going to make a new array, and we're going to make it an array literal so that we can initially give it values instantly. So we're going to give it 1, 2, 3, 4, 5, 6, 7. Okay. Excellent. Now we have to call the rotate method on that array. So we're going to go rotate array dot left rotate, and it's going to take in an array, which will be this array to rotate, and rotate by, well, our example we use 3, so let's use 3 again, and the size is 7 because there's 7 elements. So now we have rotated the array. Let's go ahead and print the results. So rotate array dot print array, and again it's going to be the same array, and it needs a size of 7. Okay, so let's go ahead and hit run to test this main method, which the main method itself tests our rotate array class, which is the solution for the question. So let's go ahead and zoom into the console and see what we got. Well, the result that we got is the same as what we expected, 4, 5, 6, 7, 1, 2, 3. So that means that our initial array, which was 1, 2, 3, 4, 5, 6, 7, it was correctly shifted, or rather rotated to the left by a value of 3. Excellent. That means our solution is correct. That test passed. Congratulations, everyone. You just solved the rotate array interview question in Java. Thank you for watching, and we will see you in the next lecture. Hello, everyone, and welcome back to our Java interview questions series. In this lecture, we're going to be solving the interview question, isomorphic strings. So the question is, given two strings A and B, determine if they are isomorphic. So first we need to know what isomorphic means. Well, two strings are isomorphic if all the characters in A can be replaced to get B. So, for example, if we have one string like egg, well, if you can replace each character in egg, which there are two different characters, to get a different string, then the two strings are isomorphic. So egg would be isomorphic to a string such as add. However, egg would not be isomorphic to a string like ego. Why? Because you can't replace the G to get B. Okay, so now we know what an isomorphic string is in relation to another string. Let's go ahead and solve this problem. How would we go about solving this? Well, we have a main class set up here in default by REPL. We can go ahead and delete the default print line, and let's go ahead and first make a maximum integer. So we can make it static for the purposes of our testing, and this is going to be the maximum number of characters that a string can have. Okay, next we're going to actually make a method that will test if these strings are isomorphic. And our thinking behind this is that we'll test each character and attempt to change it into string 2, and we'll also map each character that we already visited. So for example, if we already visited the G here, then when we visit it again, we'll have it stored that it was already visited. Okay, so let's go ahead and actually make this. What are we going to need? We're going to need a method. So let's go ahead and make a method. We can make it static again, which means it's accessible by all classes, just for the purposes of testing. And it's going to return true or false. It's going to return if string A and string B are isomorphic. So we can call this areIsomorphic. And it's going to take in string 1 as well as string 2. Okay. And it's going to test the two strings to see if they are isomorphic. So what do we need here? Well, we're going to go through each string and go through each character. So we're going to have to set a limit, some eventual limit. So the limit will be the length of these strings. So let's go ahead and make an integer called length of string 1. And it's going to store string 1 dot length. So this way we can go through from index 0 to the final index, which would be length minus 1. Okay, we're going to have to do the same with the second string. Length of string 2 equals string 2 dot length. Oh, okay. Now, there is an obvious test that we should do before we even test if they're isomorphic. And can you guess what that test is? Well, that test is, do they have the same number of characters? Because, for example, if you're trying to test two strings that are different character sizes, for example, adds, well, these two are obviously not isomorphic because they have a different number of characters. So that's what we'll test for first. We have to test to ensure that length of string 1 equals length of string 2. Otherwise, if they're not, then obviously the strings are not isomorphic. So let's go ahead and do that. If length of string 1 does not equal length of string 2, then we're going to return false because they would not be isomorphic off the bat. So we're going to say return false. Okay, great. That's the simplest condition passed. Now what are we going to do next? Now we can actually iterate through each character in the string. So we're going to have to make a variable that will keep track of each character. So let's go ahead and make an array to store this. And it's going to be an array of true or false. Has the character been visited? So let's go ahead and make that down here. Okay, we're going to make a boolean array. And it'll store true or false values. Have we visited this character before? Visited characters. You can initialize it to a new boolean. And we're going to take in size. And now what is size? Size is this 256 that we declared here. So this is going to store 256 values for visited characters. Okay. Now we're going to fill the array with the visited characters. So let's go arrays.fill. And as you can see, this will take in a boolean array and argument 1. Okay, so the first argument here should be visited characters. It's going to use that boolean array. Have we visited that character or not? The second argument is going to be boolean.false because we want to fill the array. We want to fill this array initially with false because we haven't visited any characters initially. Once we visit the character, we're going to fill it with true. So let's go ahead and do that. We're going to need first another array, but this time it's going to be storing the characters. So let's go ahead and make it an integer array.
Oh, hello everyone and welcome back to our Java interview questions series. In this lecture, we're going to be solving the interview question commonly referred to as the kth largest element in an array. So let's go ahead and look at the problem. Find the kth largest element in an unsorted array. Note that it is the kth largest element in the sorted order, not the kth distinct element. You may assume k is always valid. 1 is less than or equal to k, less than or equal to the array's length. Okay, and you'll often see some examples with this common interview question. So with this one, you would get an input. The input would be an array, something like 3, an array of integers is what you'll commonly see. And then you'll get that k would then equal 2. So this is the solution. This is the question rather, and then k would equal 2. So that would be the solution. And our task is to find how we can use an algorithm to get from A to Z. So why is k equal to 2 in this case? Well, because of what the question is asking. It's asking for the kth largest element. So in this case, if we want to get the second largest element, then this is the input, so the output we would want would be the second largest element, which in this case would be 5. And another example would be if you got an input such as 3, 2, 3, 1, 2, 4, 5, 5, 6, and you were told that k equals 4, which means you want to find the fourth largest element in the array. Well, what would the output be in this case? Well, this is the first largest, this is the second largest, this is the third largest, and this is the fourth largest. So the output would be 4. And that's because it is the kth largest element in the sorted order. So if it was the fourth distinct integer, then the answer would be 2, or rather 3, because we have 6, 5, 3, and 4. Yeah, okay. In that case, the answer would be 3. But because we have these two, which are not distinct, but they're still in the sorted order, the output would be 4. Okay, so now that we have an example, let's go ahead and look at how we would go about solving this interview question. Well, first we can write the setup code for it, which would be to make a class called kth largest element in an array. And then we're going to have a method to determine our solution. So the method would return an integer that would be the kth largest element. We can call it something like kth largest. And then it will take that array to process. So this array, it will process it to find the kth largest element. So it's also going to need to take in an integer k. So now we have a class set up for the solution and a method. Now whenever you get a question like this, before you even start writing more code, you want to write pseudocode first, which means you write out the problem with half code, half English to find the solution, and then after that you refactor it into real code. So let's talk about the solution first. Well, whenever you hear in a question that you're trying to find the largest or the smallest of an array, that is your signal that you can use a heap to solve this problem. So what is a heap? A binary heap is a data structure that is in the form of a binary tree. So it means every element in the array will be stored in a tree format. And the two types of heaps are the max heap and the min heap. And depending on whether you want to find the largest or the smallest element, you will use either the min or the max heap. So a max heap is a tree where the values are stored in descending order. So at the top, otherwise in the first slot of the tree, it will automatically, or it will be sorted so that the largest value is stored first, and that means it's the first one you can access, and then the last one stored at the end will be the smallest. And a min heap is the reverse of that, where in the binary tree, the smallest value is stored at the top in the first slot of the array, and then the rest of the elements in the tree are stored in descending order. Okay, so now we know what a binary heap is. Well, binary heaps are often used together with what are called priority queues. And this is a data type which is like a normal queue or a stack, where each element has a priority. And why do we need a priority for this solution? Well, because it's asking us to prioritize elements in the array. It's asking us to prioritize them and sort them, and then get the kth largest. So we're going to need to prioritize the input that we receive in the form of the array. We're going to have to sort this. So we can do that with a priority queue. And in a priority queue, an element with high priority will be served to us before an element with low priority. And depending on whether you have a max or a min heap that you're using with your priority queue, you will either get the smallest value or the largest value currently in the heap back first. Okay, so now we know what a priority queue is. So let's write some pseudocode for the solution of what we could possibly do to find the kth largest element in numbers. And that's in sorted order as well. It's important. It's not just the distinct elements, but each element is considered distinct. Okay. So even if there are two of the same kind, they're both considered unique. Okay, so first we're going to do is make a heap. So make a heap, and we're going to also make a priority queue. And the priority queue will hold our integers. Then we're going to iterate through the input array. So the array that we'll get, which we're calling numbers as our parameter, we're going to iterate through it and sort it. So what we're going to do is place each number in the array into a heap. And what kind of heap do we need here? Well, we're going to be needing the kth largest element. So if we put this into a min heap, then every time we iterate, we can remove the smallest element, because it will remove the first element in the priority. So if it's the min heap, it will remove the smallest. And if it's the max heap, it will remove the largest. So if we're trying to find the largest, then we want to leave the largest in the array. We don't want to remove it, so we want to remove the smallest. So we'll use the min heap into a min heap. Okay. And then if heap's size is greater than k, then we'll remove the element. And why are we doing this? Well, because k is the limit. It's the number that we're looking for, is the kth largest element. So when we get 2, we're looking for the second largest element. Okay, now because we're going to be using a min heap, it will always remove the smallest element, and so the 2 largest ones will remain at the very end. So after this if statement, we'll have only 2 left. For example, if k is 2. If k is 3, then at the end of this if statement, we'll have 3 left. And so after, when we have those remaining largest ones, we're going to remove the one at the kth slot. So return the kth element. And this will be the smaller value of the 2 left, because again, it's a min heap, so it's going to always return whatever is the smallest stored. Okay, let's go ahead and replace this pseudocode, which is mostly English in this case, and let's replace it with actual code. So first, we want to make a heap, and we want to make a priority queue of integers. So let's go ahead and do that by calling the priority queue of type integer, because we're going to be sorting integers. And then we're going to give it a name of min heap, so that we know we're storing a min heap. And we need to initialize a new priority queue on that min heap of integers. And we're going to use the constructor of priority queue to do that. Great. Okay, so we've finished this portion. Next, we need to iterate through the input array of numbers. So how are we going to do that? We can use a for each loop for that. For each loops are highly efficient, so let's go ahead. And we're going to iterate through the input array. So for int number in numbers, well, then we can iterate through each number in the input. So we've set that up. Now we're going to place each number in the array into a min heap. Okay, so we're going through each number, and we're not just going to process it as is, we're going to actually place it into our heap. That way, we're not just getting the random assortment, we're getting a prioritized assortment from smallest to largest. Because the input can be in random order, but we want to sort it into priority. Okay, so we're going to go min heap dot add number. This will allow us to add the number into that priority queue using the priority queue's add method. Okay, great. Now we have an if statement, If heap size is greater than k, then we're removing it. Okay, so let's go ahead and move that if statement into the for each loop, because we're removing that current element if the heap size has gone greater than k. We only want to leave a k number of elements in the heap. That way we can return the kth element. Okay, so if we have to replace this pseudocode with code, if the heap size, we can get the heap size by going minHeap.size, which is a method in the priority queue, then greater than k. And we can leave k as is k because it is the parameter we're getting as an input. Okay, so as soon as there are more elements than the element we want, which would be, for example, if we wanted the fourth largest element, then we want to leave 4 remaining, and that would be the 4 largest would be remaining because they would be at the end, and we're removing the smallest one, and then the next smallest one, then the next smallest one, until we leave 4 of the largest ones, if k was 4. Okay, so to remove the element, we call minHeap.remove. So we're going to be removing the current element that we're at, the current number, in our priority queue. And this will always remove the smallest element because it's a min heap. Okay, it will always remove the smallest one as the for each loop loops through the entire priority queue. Okay, we still have this. We need to return the kth element. And to do that, we want to return the next item that would be removed. So after we've hit k, the next item that we could remove, that would be the kth smallest. For example, if we had 8 initially, and then we're going to remove all of them in order of the smallest ones first, so in ascending order, we're going to remove all of them until we have, for example, 4 left. And then once we have 4 left, when we return the fourth one, that will be the 4th largest. And then the remaining 3 would be even bigger than that, bigger than the 4th largest. Okay, so we're going to return the next element that we would remove. minHeap.remove. Because at this point we would have the kth one ready and first in queue. Alright, let's see if we have any more pseudocode. Well, we just have the default main class made in REPL, which is the website we're using to run this code. Okay, we have removed all the pseudocode and replaced it with code. And that is the solution. Let's see what it's telling us in the compiler. New priority queue. It wants us to import the priority queue up top, so we can do java.util. Asterisk, I believe. REPL doesn't come with a default suggestions for importing. So if you're using an integrated development environment, you can import priority queue. And, okay, yes, this will import to the priority queue. Import the java.util package with an asterisk at the end, and all the console errors will disappear. Okay, so that is all that you need to solve this interview question. Thank you for watching, and we will see you in the next lecture. Hello everyone, and welcome back to our Java interview questions series. In this lecture, we're going to go ahead and check our solution by running it in the main method. So let's look at how we would do that. First, we're going to need an object to access the method we made in the object. So let's go ahead and go up here and copy the class name to make a new object. We're going to call it question. We're going to initialize it to a new object of type kth largest element in an array. Okay, now we can call the question dot find kth largest method. So we're going to go ahead and take this method, and we're going to need some parameters for it in order to call it. So since we already know the answer to this input, let's go ahead and use this array and this k, and we should be expecting an output of 4. So down here in the main method, we can initialize a new array to contain those exact values. So we'll make an integer array, and we can call it array, equals an array literal that we can make with these values exactly. Okay, great. And now we have k is 4. We can just hard set that in to the arguments. So we're going to pass in array as our array argument and 4 as our k argument. Okay, let's store this in a value itself, because remember it's returning an integer, so we can return answer and then we can print the answer to the console. And remember, we're expecting a value of 4. So we have made a new object to use its method, then we have made an array, and we have called a method and printed the result, and the console has printed 4. Great! Now we know our solution works. So if yours doesn't work, make sure you test your code against ours, check your code. In fact, it's always a good idea to test twice, especially if you do test-driven development. Then you'll know to always have 2 tests at least for each method. So let's go ahead and make another test. To do that, we can make another array, and this time we can call it array1 and put in these values and a k of 2. And this time, what were we expecting? We were expecting an output of 5. Okay, great. Let's go ahead and do that. We're gonna have to make another variable. We can call it answer1 to differentiate them. So we were expecting 2, and this is called array1. Then we can go ahead and print answer1 to test our method a second time. So we're just testing that when we put in an array, we are getting the kth largest element in that array, regardless of the number of items in the array. For example, even though there were 2 5s here, they were each considered distinct. Okay, great. We got 5 in the output for that method, which is exactly what we wanted, because the second largest element in this array is 5. Thank you for watching, and we will see you in the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.